Welcome to This Explainer. Today, we're unpacking the two fundamental movements of our planet and how they dictate absolutely everything, from the exact time your morning alarm goes off to whether you're pulling out a heavy winter coat or a lightweight t-shirt. We're talking about the motions of the Earth. It's a fascinating tale of two completely different yet perfectly synchronized movements that literally govern our existence. Here is our roadmap for today. First, the Earth's invisible lines. Second, rotation. Third, revolution. And finally, the dance of seasons. All right, let's jump into section 1, the Earth's invisible lines setting the geometry. Now, you obviously can't see this from a spaceship, but there is a distinct mathematical scaffolding governing our motion. The absolute most crucial part of this is the axis. I want you to imagine a perfectly straight line piercing through the North Pole, running directly down to the South Pole. That is the center point around which the entire planet spins. But here's the really critical detail. This line isn't perfectly straight up and down relative to its orbit. It's tilted, and that fact is going to be incredibly important later on. Right alongside that tilted axis, we have the equator. This is an imaginary horizontal line that slices the globe perfectly into two equal halves, giving us the northern hemisphere on top and the southern hemisphere on the bottom. And just like that, our planetary stage is officially set. Moving right along to section 2, rotation, day and night. So let's dive into our very first planetary motion, which is rotation. This is the continuous spinning of the Earth around its own axis from west to east. Because of this constant spin, only one half of our globe faces the sun at any given time. The sun-facing side gets to experience the bright heat of day, while the opposite side is temporarily cast into the dark shadow of space, giving us night. Taking exactly one full day, so 24 hours, to complete one single rotation, this specific west to east movement is the sole reason you experience a continuous cycle of waking up to sunlight and going to sleep in darkness. We obviously can't feel the Earth spinning beneath our feet, but we witness the spectacular evidence of it every single morning. Up next, Section 3, Revolution, the yearly orbit. As if spinning continuously at thousands of miles an hour wasn't enough, right? The Earth is also simultaneously cruising along this immense, imaginary path around the sun. This motion is called revolution, and as you probably know, it takes exactly 365 days to complete one full orbit, which defines our standard Earth year. But you know, the exact math is actually a little bit messier than that. The true time it takes to complete that orbit is 365 days plus an extra 6 hours. And those leftover 6 hours from each yearly journey, well, they don't just disappear into the void of space. Instead, our calendar actually saves them up. Every 4 years, those extra 6 hours mathematically stack up to a full 24 hours, meaning one whole extra day. This gives us what we call a leap year, marked by 366 days. We beautifully accommodate this little astronomical quirk by simply tacking an extra day onto the month of February every 4th year. So, to synthesize this whole shebang, these two massive movements are happening at the exact same time. Rotation is the spinning of the Earth on its axis, and that governs our daily 24-hour cycle of light and dark. Revolution, on the other hand, is the physical journey around the sun, which governs our massive 365-day calendar. And that brings us to Section 4, the dance of seasons. This is where it gets really cool. When you combine this sweeping yearly revolution with that tilted axis we highlighted right at the beginning, you get the absolute magic of our climate, the 4 seasons. Because the axis is permanently tilted, one hemisphere is always leaning towards the sun, while the other leans away. The hemisphere leaning inward gets direct heat and those nice, long summer days. At the exact same time, the hemisphere leaning away gets far less sunlight, meaning they're experiencing shorter days and a freezing winter. This beautiful combination of tilt and orbit creates a highly precise annual timeline of astronomical events, specifically in the Northern Hemisphere. On June 21st, it tilts maximally toward the sun for the summer solstice, the longest day of the year. By September 23rd, it hits the autumnal equinox. Then, on December 22nd, it tilts fully away, giving us the winter solstice and the longest night of the year, before finally cycling all the way back to the spring equinox on March 21st. Here is a super fun linguistic detour for you. The very word we use for these extreme points of summer and winter, solstice, literally translates from the Latin words sol, meaning sun, and stitium, meaning to stop. Sunstop. It perfectly describes that peak moment of the Earth's tilt when the sun's apparent path across our sky seems to just freeze in place before reversing direction. On the flip side, during the equinox transition periods in March and September, neither hemisphere is tilted towards the sun. The sun's rays fall perfectly, vertically straight onto the equator, and the result? The entire planet experiences exactly equal lengths of day and night. We're talking 12 hours of daylight and 12 hours of absolute darkness, perfectly balanced. Okay, let's lock all of this in with a quick treasure box summary. First, rotation. The Earth spinning on its axis, taking exactly 24 hours and causing our daily cycle of day and night. Second, revolution. The Earth moving in its massive orbit around the sun, taking 365 days and 6 hours, which, when combined with the Earth's tilt, causes our shifting seasons. Knowing that absolutely everything, from our freezing winter snowstorms to our long, balmy summer evenings hanging out with friends, depends entirely on that simple, imaginary tilt as we hurtle through space, I want to leave you with this provocative thought to ponder. How drastically would your daily life, your wardrobe, and our entire global climate change if the Earth's axis wasn't tilted at all? It really kind of reorients how you see our place in the universe, doesn't it? Thank you so much for joining me for this explainer today, and keep exploring the incredible mechanics of our world.